first one, the figure is here. You are given one information. What is it? AB side parallel to DC side, and we have to prove here ADC angle. ADC angle, this one. ADC angle equal to BCD. This one. We have to show these two angles are equal. Now here we got one information, that's AB side parallel to DC side, right? Then if these two sides are parallel, we can consider alternate angles. This angle and this angle. Let's put A here. Then this one also should be A because of these two angles are alternate angles. Then we can write BAC angle equal to ACD angle. ACD angle. What is the reason? Alternate angles. Right? Alternate angles. Now see. And this one, if we consider BC chord and this segment, you can clearly see this angle and this angle are equal. Why? Because these two angles are in the same segment. If this is A, this one also should be A. Then we can write BAC angle equal BDC angle. BDC angle. What is the reason? Same segment. Same segment. Angles are in the same segment. Then, right, we got BAC angle equal to BDC angle. Then we can clearly see these two angles are also equal. Then we can write this one BDC angle equal to this one. What is this one? ACD angle. ACD angle. We proved it. Then now consider this chord and this segment. Now what happened? AD. I'll put B here. ADB angle and this one. ACB angle. This one. These two angles are in the same segment. This segment. Then we can write ADB. ADB angle equal to, and this one, ACB angle. ACB angle. What is the reason? Angles in the same segment. Angles in the same segment. Now, see this one here, A. These two angles are equal and these two angles are equal. Then we can write this whole angle equal to this one. Then let's put 1 here and 2 here. Now let's add these two together, 1 and 2. BDC. BDC. This angle. BDC. BDC. This angle plus ADB. This angle. ADB equal ACD plus ACD. ACD. This one. ACD plus ACD. ACD. This one. ACD. Now let's add. When we are adding these two angles together, we can take ADC angle. ADC angle. And we are adding these two angles together, we can take BCD angle. Right, we have done it. Okay, the second one. So here we have to prove PQ line. PQ line. This line is parallel to SR. This line. And only one information is already given. What is it? This here X. The center should be X. So PX side equal to QX side. Then we know if we consider PXQ triangle, that's an isosceles triangle. Then these two angles also should be equal because this is an isosceles triangle. Then if this is A, this one is also should be A, then we can write QPR angle equal to QPR angle equal to PQS. PQS. What is the reason? Isosceles triangle. Right. Now see this one. This triangle, this angle and this angle. If we consider this angle and this angle, now let's consider QR code and this segment. These two angles are in the same segment. Already we know the theorem. What is? Angles are in the same segment are equal. Then if this is A, this one is also should be A. Then we can write QPR angle equal QSR angle. What is the reason? The reason is angles are in the same segment. Then we can write same segment. Now carefully look at here. Here then you can clearly see this angle and this angle also equal. Then we can write, because here it's A and here also it's A. Then we can write PQS angle. PQS angle and QSR angle also equal. And now again carefully look at these two angles are alternate angles. Right? Alternate angles. Then when alternate angles are equal in magnitudes, what happens? We can say PQ line parallel to SR line. The third one we have to prove AX equal DX. AX, this one equal to this one, DX. And here you are given AD line is parallel to BC line. Then we can consider alternate angles because these two lines are parallel to each other. Then we can clearly see ADB angle equal to DBC angle. Then if I put A here, I can put A here as well because these two angles are alternate angles. Then we can write ADB angle equal to DBC angle. DBC angle. What is the reason? It's alternate angles. And now consider this angle and this angle. Now see this one, BC chord and this segment. Now this one, this angle and this angle are in the same segment. Then if this is A, this angle also should be A. What is the reason? Because these two angles are in the same segment. Then we can write DAC angle equal to DBC angle. DBC angle. What is the reason? It's same segment. Angles in the same segment. Then now we can clearly see these two angles got equal. Then we can write ADB angle ADB angle equal to BAC angle. Then if we consider this triangle, ADX triangle, what happened? These two angles are equal now. Then we have learned when opposite angles are equal, opposite sides are also equal in a triangle. Then we can identify this one is an isosceles triangle. Therefore, we can write here isosceles triangle. Isosceles triangle, and therefore we can say AX. This side AX equal to this side BX because isosceles triangle. In the fourth one, we have to show AXC. AXC. This angle is equal to AYB. AYB. This angle. We have to show that these two angles are equal in their magnitudes. Okay, now let's prove it. So here we can clearly see, if we consider this segment, if this is the chord BC, you can clearly see this angle and this angle should be equal because these two angles are in the same segment. Then let's put some letters. If I put A here, this one is also should be A because these two angles are in the same segment. Then we can write BAC angle equal to BYC angle. BYC angle. What is the reason? Angles are in the same segment. Same segment. Right. Then see this one. Now this is a straight angle and this is also straight angle. Then the magnitude, right? Magnitude of a straight angle is 180 degrees. Then if we find the magnitude of this angle, it should be equal to 180 minus A. Right, now let's write this one. AXC angle. AXC angle equal to, because now this is the straight angle, okay? We know the magnitude of a straight angle, it's 180 degrees. Then this is A. Then we can find the magnitude of this one. We can subtract A from 180. Then now this one also a straight angle. Then magnitude should be 180. Then we can find the magnitude of AYB angle as well. AYB angle also 180 minus A. Then what happened? What happened? This side got equal. Then we can say therefore AXC angle equal AYB angle. Next one. Here you are given one information that BPQ equal BP. Where is P? Here. BPQ equal to BRQ. BRQ. Here you are given these two angles are equal. Now I put A here. Then this one also should be A. Then we can write BPQ equal BRQ because it's given, right? And we have to show BE is the bisector of AEC angle. Then we know if BE is the bisector of AEC angle, these two angles should be equal. Then we have to prove it. Now let's see this one. If this is A, this one also should be A. Why? Because these two angles are vertically opposite angles. Then we can write BAB, BPD angle equal to APE. APE angle. What is the reason? Vertically opposite. Vertically opposite angle. Right. Then this one also should be A. And now consider this chord and this segment. Now all these angles are in the same segment. Then we can write. So now let's put a letter. I'll put letter B. EAD angle. EAD angle equals EBD angle equals ECD angle equals B. What is the reason? Same segment. Angles are in the same segment. Right here, this one equal to A, okay? A. And then we can say, now clearly see this one. Here we can see a triangle. Here we know this angle is B and this angle is A. Then if we want to find the magnitude of this angle, we can subtract A and B from 180 degrees because the sum of the interior angles of a triangle is 180 degrees. Then we can write AEB angle equal 180 degrees minus A plus B. And now see this one also here, DEC angle. And consider this triangle. I think you can see this triangle. See what are the interior angles of this triangle? This one and this one and this one, right? And here angle is A and here angle is B. Then if we want to find the magnitude of this angle, we can subtract the sum of the magnitudes of these two angles from 180 degrees. Then we can write BEC angle equals 180 subtract here A and here B. Then we can subtract the sum of these two angles. Right now what happened? This side is equal. Then we can write therefore AEB angle equal to BED angle. Now what happened? These two angles got equal. Then if these two angles got equal, then we can say EB is the bisector of AEC angle. Therefore BE is the bisector of AEC. Okay, let's see the next one. Here you are given one information. What is it? If AB equal AC, AB equal AC, AC is this one. It means if we consider this ABC triangle, these two sides are equal. It means ABC triangle is an isosceles triangle. If this is an isosceles triangle, we can take these two angles are also equal. Let's put some letter. I put A here, then this one also should be A. Now let's see what we have to prove here, right? Show that CDX equal CDX, this one. CDX angle equal 2 times ABC. ABC. Okay, it means you have to prove that this angle is twice of this angle. Okay. Now let's prove it. I just consider BBC triangle. If we consider this BBC triangle, this CDX angle is an exterior angle of this triangle, right? So the magnitude of this exterior angle should be equal to the sum of these two opposite angles in the triangle. We have learned it. Now let's see how to prove it. Right. Okay, now see this one. If we consider this AD chord, then and this segment, we can clearly see this and this angle. This angle and this angle. Okay? So this one is A. Now let's put B here. I put B here, right? B. If this is B, this one also should be B. Why? Because these two angles, this one and this one, see, these two angles are in the same segment. Then we can write, first let's write these two angles are equal. Still we haven't written it. Then let's write ABC angle equal BCA angle. BCA angle. The reason is isosceles triangle. Right. Then we consider this chord and this segment. Then we can write ABD. Here we got A. ABD. ABD angle equal to this one. ACD. ACD angle. The reason is these two angles are in the same segment. Right? Same segment. Same segment. Now, here, I told you consider this triangle, this one, okay? BCD triangle. See, I'm drawing here BCD. BCD triangle. Then this whole angle is A. Then you can find what is the magnitude of this one, because already we know the magnitude of this angle as well. Then we can find this one. This whole one is A. Then we can subtract this part and we can find the magnitude of only this part. Then it's A minus B. Then this angle should be A minus B. And this one. So we are considering this triangle. Then this angle should be A plus B. Then here A plus B. Right? So now BCD triangle, and then I told you CDX is an exterior angle of this BCD triangle. Then we have learned the magnitude of an exterior angle of the triangle is equal to the sum of two opposite angles. Then let's write CDX equal, then this one is A minus B. BBC angle equal A minus B, because we got some letters to denote, and plus A plus B. A plus B. Right. Now say here minus B and plus B we can cancel out. Then we got CDX equal A plus A, we can write 2A. We can write 2A. Now say here A is equal to this whole angle. What is this whole angle? This whole angle is ABC. Then instead of this A, we can write ABC, because this angle is A, this whole angle is A. Then instead of this A, we can write ABC. ABC. Then CDX angle equal 2 times ABC. Therefore, we can write CDX angle equal 2ABC. That's it. You are given one information. What is it? XB, XB, this side. XB equal to XC, to this one, right? These two sides are equal. And what we have to prove here, we have to prove that AC equal to BD. AC is this one, this side is equal to BD. BD is this one and this one. We have to show these two sides are equal. Right. Now, how we can prove it? Here, look at here. You can clearly see there are two triangles, right? So one is AXC and the other one is DBX. Okay, now let's write ACX triangle and the other one DBX triangle. Right. Now see here, if we consider ACX triangle, ACX triangle, we got the CX side as one side of this triangle. And if we consider this triangle, we got BX side also as a side of this triangle. And we are given these two sides are equal. Then we can write XC equal XC. ACX. I got ACX triangle first. Then I can write XC. XC side. XC side equal XB because it's already given. Right. And now, see this one also. If we consider AB, AXC triangle, this angle is an interior angle of that triangle. And also, if we consider DBX triangle, this angle is an interior angle in that triangle also. Then we can say this angle is a common angle for both of these triangles. Then we can write AXB angle is equal to AXB. What is the reason? It's common for both of these triangles. Common angle. Right. Now let's see this one. If we consider this 3D chord, you can see this segment. So see this one, this angle and this angle. See, are in the same segment. Then these two angles should be equal. That is the reason. Angles are in the same segment. Then we can write BA. I got ACX and triangle first. ACX. Okay, then I can write BAC angle equal to BDC. BDC angle. The reason is same segment. Angles are in the same segment. Now, one side equal, two angles are equal. Then we can say, therefore, ACX triangle congruent to BDX triangle. What is the case? One side and two angles. AS. Angle, and side. Then we know if these two triangles are congruent, corresponding elements are equal. Now see here, AC is opposite side to this common angle, and this BD side is also opposite to this common angle. Then these two are corresponding elements. Then we can write, therefore AC equal BD. What is the reason? corresponding elements. Corresponding elements. Right, we have done it.